All right, so this lesson is on solving quadratic equations, and this is where we are pulling together everything that we have learned so far in order to determine specific information involving a quadratic relation. So here on the right-hand side we have a quadratic relation. It's a graph, and we also have the equation represented in vertex form of this quadratic relation. And what we're going to do is we're going to look at what does it really mean to solve. And it's not that when I say solve, or when you're asked to solve something, that you're finding a specific property, such as finding the zeros or finding x-intercepts or the vertex or the axis of symmetry. What you're doing is trying to find out a specific bit of information about this quadratic relation. It could be the x-intercepts, but it could also be something else. Now, when we're solving, we can actually do this a number of different ways, and it depends on the representation that we have. We can solve something algebraically, and we have a number of different ways to solve algebraically. It also depends on what form we're given, and we can also solve using a graph. So what I'm going to do is I'm going to go through and I'm going to show examples of how we can, in this case, I've got the algebraic representation, and I also have the graphical representation, and show how the two connect, because that's an important bit of information, is that how do we connect our graph that we have to our equation when we're solving, so that we can stop sometimes if we've got both representations and think, okay, well, does this make sense? Does this make sense based on the information that I have? So let's start off by solving. So I have the equation y equals x minus 1 all squared minus 9. And I want to solve when, let's say, x is equal to 2. So we're going to solve when x is equal to 2. So we can do that either algebraically or graphically. We're going to do it both ways so that we can see the connection. If I'm solving it graphically, what I'm going to do is I'm going to go over to the graph. So here I've got the graph. I'm going to go over to where x is equal to 2. So this is here. And I'm going to go down until I hit the graph to see what that value is. And here I see that's equal to -8. So that means that I'm going to choose a different color here. So this is x equals 2 here, and I'm going to come down to here, and that is the point to -8. Now, so that means I've actually just solved it. I'm trying to find the value of y when x is equal to 2. Now, if I want to check to see if this is actually true, I have the equation, and it's just a verification, because we don't actually really, I mean, graphically it looks like it's -8, and I would tend to agree with that. But let's just do a quick check. And how we can do that is we can substitute 2 -8 into our equation and see if our left-hand side equals our right-hand side. So I have y is equal to -8. So I go -8 equals 2 minus 1 all squared minus 9. So I have -8 equals 2 minus 1 is 1 all squared minus 9. I have -8, well, that doesn't look very good, there we go, equals 1 minus 9 minus 8 equals -8. My left hand side equals my right hand side, and so I know for a fact that it's true. Now, what if I didn't have the graph? What if I only had the equation? Well, what I can do, again, is substitute in directly and solve for y. So I'm going to show that process right now. All right, so I've just moved everything up slightly, and what I'm going to do now is solve when x is equal to 2, and I'm just going to do that algebraically. So the original equation is y equals x minus 1 all squared minus 9, and I'm going to substitute in when x is equal to 2. So y equals 2 minus 1 all squared minus 9, y equals 1 all squared minus 9, so that is y equals 1 minus 9, and coming up here I have y is equal to negative 8. And I can check again because I have the graph, so I can check to see if that makes sense, and yes it does. So when x is 2, y is equal to negative 8. And that's really what solving is that we have an equation and we can solve it algebraically and we can also solve it graphically. We've now looked at solving when x is equal to something. Now what we'll do, or x is equal to a value, so now what we'll do is we'll look at solving when y is equal to a value. All right, now we're going to solve when y is equal to 0. We know that on a graph, that's really where the x-intercepts are, so that will be here, and that will be here. So according to the graph, where y is equal to 0 are at these two spots, and that is negative 2, 0, and also 4, 0. So now I'm going to solve this algebraically. We're going to check to see, okay, well, you know, if I rearrange the equation, will I end up with x-intercepts of, or x values of negative 2 and 4? Alrighty, so my equation is y equals x minus 1 all squared minus 9. I'm going to substitute when y is equal to 0. So now I'm solving, so I want to find the value of x that's going to make this true. So in vertex form, I can just straight rearrange. I have an equation with one unknown. So I'm going to add 9 to both sides. So I have 9 equals x minus 1 all squared. Now my next step is to take the square root of both sides, and don't forget we have two possible square roots. We have a positive square root and a negative square root, so I have plus or minus. The square root of 9 is equal to x minus 1, and actually I could get rid of the brackets. I don't need those anymore because they were only there for the square root. Alright, so now this is where I branch off because I have two possible solutions. I have the negative square root of 9 equals x minus 1, and I have the positive root of 9 equals x minus 1. So I have minus 3 equals x minus 1, and I have 3 equals x minus 1. So now solving for x, I'm going to add 1 to both sides, so this is negative 2 equals x. And I'm going to add, so 3 plus 1 is 4 equals x. So there we go. So we ended up, we have the same values, and this makes sense. And so this is where you would check with your graph and you go, okay, yeah, that makes sense. I've got algebraically, I have found I have x is negative 2, and ooh, look at that. That's negative 2. And when y is 0, x is also 4, and that's true here also. So you can say, okay, that makes sense. But what the calculations that I've done fit with what's on the graph. All right, so now what if I asked solve when y is equal to 7? On the graph, and this is a common mistake that students make. Students, it's interesting. Students will go up to y equals 7, which is here. Now, if I draw a horizontal line, that wasn't a very good horizontal line, right? Exactly where x is equal to or y is equal to 7, but you'll forgive me. It crosses twice. It crosses here and it crosses here. So there's two possible values for x when y is equal to 7. And if we look here, it's, if I bring this down, it's there and there. So this is negative 3. Actually, I'm going to put it up here. So this is negative 3, 7, and this is 5, 7. All right, so now I'm going to solve the equation where y is equal to 7. So I have 7 is equal to x minus 1 all squared minus 9. I'm going to, as with the previous one, I have an equation with one unknown, so I can rearrange it. I'm going to add 9 to both sides, so that gives me 16 equals x minus 1 all squared. I'm going to take the square root of 16, but not forgetting we have a positive and a negative square root. And this is where I branch off. So I have the negative root of 16 equals x minus 1, and I have the root of 16 equals x minus 1. So this is negative 4 equals x minus 1. This is 4 is equal to x minus 1. I'm going to add 1 to both sides, so I have minus 3 equals x, and I'm going to add 1, so I have 5 equals x. And if we look here, again, this matches what we have. I have x equals minus 3, x equals 5, and that's what I find out here. So that is making the connection between what we have here algebraically and what we have here graphically. What does this really mean? Okay, so, and checking, okay, yes, this does make sense that I have two possible solutions. Now, what if I asked you to solve when when y is equal to negative 10? If we look at that on the graph, which is right here, the graph actually doesn't go that low. And so you would expect that there would be no solutions. So I want to look at how do we demonstrate this algebraically. All right, so I'm going to substitute in where, whoopsie, y is equal to negative 10. So I have negative 10 is equal to x minus 1 all squared minus 9. I'm going to rearrange, so I'm going to add 9 to both sides. So I have minus 1 equals x minus 1 all squared. This is a bracket, not a 1. All right, I'm going to take the square root of both sides. So plus or minus the square root of negative 1 equals x minus 1. And this is where we stop. And the reason is because I cannot take the square root of a negative number. And since I can't take the square root of a negative number, this means that I have no solutions, or there's no roots. So I would actually say, since I cannot take the square root of a, whoopsie, negative number, there are no solutions. And that makes sense when we look at the graph. We would expect there's no solutions because negative 10 is down here. It doesn't go in, it's not going to touch the graph. If I draw a horizontal line across here, it does not touch the graph anywhere. So there are no solutions. Okay, so we've looked at solving graphically, we've looked at solving algebraically when the quadratic relation is in vertex form. But what if we're given something like this? So you're going to solve 0 equals x squared plus x minus 6. And you need to solve that algebraically. We have seen this many times, that you can't just rearrange an equation that's in standard form. And that's because we have not only an x term, but we have an x squared term. And we can't simplify these together. And so what we have to do is change forms. And since we're trying to find when y is equal to 0, that's the zeros, trying to determine the zeros, and so the best thing to do is to go to factored form. And so first we need to check to see, is this factorable? Alrighty, so we're going to try to factor this. So I'm going to create my chart. and we have x squared, and this is minus 6. And so we know that these two have to add to 1x, and these two also have to multiply to the same as these two, which is negative 6x squared, or negative 6, because we're just kind of looking at the coefficient. All right, so they need to multiply to negative 6 and add to 1. So we know that we'll need to have a positive and a negative number, so let's just try 3 and negative 2. So 3 and negative 2. If I add those together, I get 1, and that's good. So I'm going to put 3x here, negative 2x here, and now I'm going to common factor out my rows and columns. So the common factor here is x. Common factor here is negative 2. The sign stays with the line. Up this way we have x, and up this way we have 3. So we have our factors, so we have 0 equals x plus 3 times x minus 2. All right, so we are in factored form, and so in order to solve, what we'll do is we'll take each factor, I branch off, and I set them to 0. So I have x plus 3 equals 0, x minus 2 equals 0, so x equals minus 3, and x is equal to 2. Those are my two x-intercepts. So these are the two values of x that will make the equation true, or make the left-hand side equal to the right-hand side. Now here factoring is the most efficient method. There's actually 3 other methods that we could use, 2 other algebraic methods, which are to convert this to vertex form and solve, and we've seen a few examples of that already. Or we could use the quadratic formula. The quadratic formula, substituting in a, b, and c, and determining the x-intercepts that way. The other way is to graph it. So if I could create a table of values and graph, and see if we can determine what the x-intercepts are that way. All right, so now we're going to solve this particular equation. We have negative 4 equals negative 2x squared plus 7x plus 11. And so I've included the graph here so that we can kind of look at what's happening. So if I go to my graph and I look at where y is equal to negative 4, so I'm just going to switch colors here. This is where y is equal to negative 4. I'm going to draw a horizontal line. So this horizontal line crosses the graph twice, once here and once here. And so if I look and go, well, you know, I can't really read this point very well. I would say that it's approximately, I mean, this is not the best in terms of what I've done, but probably around negative 1.5. And this I would say is at 5. I'd say this is probably negative 1.5. It might be negative 1.6, not 100% sure. And so this is where graphical methods aren't always the best, because we can't actually tell what the exact value is. So our only other option is to solve this algebraically. Now when I look at this, I say, okay, well, I've got y is equal to negative 4. I've got standard form, and so I can't solve this directly because, again, I've got an x squared term and I've got an x term. And so there's a couple of possibilities here. I can either convert to vertex form and solve it that way. I could also go to factored form, or I could use the quadratic formula. Now, when we are factoring or using the quadratic formula, the one condition is that we are finding the x-intercept. So that's when y is equal to 0. Y is not equal to 0 here. Y is in fact equal to negative 4. So in order to either factor or use the quadratic formula, I'm going to have to rearrange this, and so that this is equal to 0. So I'm going to go ahead and do that. I will have, I'm going to add 4 to both sides to get rid of this negative 4, so that gives me 0. Minus 4 plus 4 is 0. equals negative 2x squared plus 7x plus 15. And so now we have this new equation. Now, what we have to think about is what in fact have we done graphically? What we have done is we have taken the entire graph and we actually are shifting it, all the y-coordinates, up 4 points, or up 4 units on the graph. And what I'll show later is a picture of the graph shifted up 4. All right, so let's go ahead and solve this. And so what I'm going to do first of all is I'm going to try to factor it. As I've mentioned many times before, always common factor first, and I'm going to common factor out the negative. So I'm going to have 0 equals negative 2, negative bracket 2x squared minus 7x minus 15. And I'm going to put all of that into the chart. So I have 0 equals negative, and then I have my chart. And we know that 2x squared goes here and minus 15 goes there. And I will need to have two numbers that will add to this middle term, so they'll go here, and also multiply to what 2 times 15 is. And I'm just going to move my graph out of the way slightly and work that way. So I need two numbers that will multiply to minus 30 and will add to minus 7. So factors of minus 30 are, because one has to be negative, one has to be positive. I'm going to go with minus 6 and 5. And so those multiply to minus 30, but when I add them, we get negative 1. So I'm going to try negative 10 and 3. So minus 10 plus 3 is minus 7, so those are our two. So I'm going to put negative 10x here, and I'm going to put 3x here. Common factor my rows and columns. I'll have 2x here. I'll have 3 here. Up this side I have x, and up this side I have minus 5 because the sign stays with the line. So when I write this out, I have negative 2x plus 3x minus 5. So I was able to factor it, this is it in factored form. All right, so I've just moved everything up, and I'm going to take each factor and I'm going to set them to 0. So I have 0 equals 2x plus 3 and x minus 5 equals 0. So rearranging, I have negative 3 equals 2x, and I have negative 3 over 2 equals x, and on this side I have x equals 5. And when I pull this back into play here, if I look, negative 3 halves is negative 1.5, so my estimate was about right, so 1.5 and 5. And that's the solution to our equation. So what I want to do now is just explain what's happening graphically when we do the rearranging. So we originally started off with this equation, minus 4 equals negative 2x squared plus 7x plus 11. And in order to solve it by factoring, we have to make sure that this is equal to 0. And so when I do that, so I'm going to add 4 to both sides again. So I get 0 equals negative 2x squared plus 7x plus 15. And so what you can see is that on this particular graph, I actually have both of those. Red is the original one, this one here, and blue is this one here. And so what's happened is, and think back to transformations, I have taken every y value and I have added 4 units to it. So originally, this here was where y is equal to -4 on the original graph, here and here. And what I've done, when I've shifted everything up 4 units, if I draw a vertical line up, it brings us to where the zeros are on the blue graph. And that's what's happened. And that's why we can factor this in order to solve the equation. And that's because we are looking for the x-intercepts. I can also do this and use the quadratic formula. I can't use the quadratic formula or factor when this is equal to -4, because it only works when we're trying to find the x-intercepts. In order to find the x-intercepts, what we need to do is translate the graph up 4 units so that y is equal to 0. And that's the only way that this will work. And often students will make the mistake and they will factor this instead of rearranging and factoring this, or use the quadratic formula here instead of rearranging and going to here. It does not work if you try to factor it from here, or if you use the quadratic formula from here. You will not get the right answer because you are looking for the zeros. And in this form, you are not looking for the zeros, you are looking for the value of x when y is equal to -4. So now what we're going to do is we're going to look through some examples where actually I would like you to do these. Try to figure out what's the most efficient way to solve these. And then once you've done them, I will end up taking them up. So please pause the video as you try them. So the first one is 7 equals -3 x squared minus 4x plus 12. The second one is 0 equals 6x squared plus 17x plus 5. The third one is 24 equals 2x minus 3 all squared minus 8. The fourth one is 0 equals 2x plus 5, 3x minus 7, and finally the last one is 7 equals negative 5x minus 2, x plus 5. So what I'd like you to do is please pause the video and try to work through these. I will work through them in order, so I'll do number 1, 2, then 3, then 4, then 5. And so that way you can skip through if you just want to see if your answer is correct. All right, so let's go through the first one. So we have 7 equals negative 3x squared minus 4x plus 12. So this is in standard form. We can't solve this directly the way it is because we have an x squared and an x term. So what we'll need to do is change forms. So we can either try to factor it, or we may have to use the quadratic formula depending on the situation. So I am going to, first thing, I can't factor. Now I mentioned this before. If I was going to factor or use the quadratic formula, this would have to, y has to equal 0. And in this case, y does not equal 0, so I'm going to have to rearrange this so that y is equal to 0. So the first thing I'm going to do is I'm going to subtract 7 from both sides, because 7 minus 7 is 0. So that would give me 0 equals minus 3x squared minus 4x, and 12 minus 7 is 5. All right, so we are now equal to 0, so we can try to factor this. That's the first thing we should try to do. And what we'll do is we'll, when we're factoring, we're going to common factor out the negative. So I have minus 3, and that's in brackets, x squared plus 4x minus 5. And now I'm going to put that into my chart to see if I can factor it. So I have my negative there, so I have 3x squared here, and I have minus 5. So what I need to do is I need to find two numbers that will multiply to minus 15, because that's 3 times negative 5 is minus 15, and add to 4. Well, I already know that doesn't work, because factors of minus 15 are 3 and 5, or negative 3 and 5, or 3 and negative 5, or negative 15 and 1, or 15 and negative 1, and none of those add up to 4. So I know that's not going to work, so this is not factorable. So I'm going to have to use the quadratic formula. So, not factorable. Alright, so therefore use quadratic formula. Alrighty. So when we're using the quadratic formula, we're going to be using it on this one here, all right, because it's equal to 0, all right. So we know that in this case, A is equal to negative 3, B is equal to negative 4, and C is equal to 5. So what I'm going to do is I'm going to break this up here, and I'm going to use the quadratic formula over here. So I have x is equal to minus b plus or minus the square root of b squared minus 4ac, all divided by 2a, and I'm going to substitute in my values for a, b, and c. So I have minus, I'm going to move that over a bit. I have minus 4 plus or minus the square root, and I have minus 4 all squared, minus 4 times a, which is minus 3, times 5. And that is all divided by 2 times minus 3. So I have x equals 4, because minus 4 is 4, so plus or minus the square root, minus 4 all squared is 16. That's not a very good 16. 16. Then I have minus 4 times minus 3 is positive 12. 12 times 5 is 60, plus 60, all divided by negative 6. So I have x equals 4 plus or minus the square root of 76, all divided by negative 6. Alright, so this would be the exact answer, so 4 plus or minus the root of 76 over negative 6, but we'll branch off here. So I have x equals 4 plus the root of 76 divided by negative 6, or I have 4 minus, whoopsie, x equals x equals 4 minus the root of 76 divided by negative 6. So that is x equals minus 2. It's 1196, so I'm going to go with 2.12. And x is equal to 0.7863, so we'll go with 0.79. And so those are the two possible values for x when y is equal to 7. Alright, so for the second one, we have 0 equals 6x squared plus 17x plus 5. And so that doesn't really look like a 17. Let's fix that. 1, 17x plus 5. So again, we're in standard form. It's hard to, well, we can't solve it in this form, so two possibilities are to change it to factored form and solve it that way. Use the quadratic formula. The other option is to go to vertex form and solve. There's nothing wrong with that, it just takes longer. The quadratic formula is essentially that, and you should have discovered that in class. So here we go. All right, so I'm going to try to factor it. So I've got my chart. And I have my 6x squared here, and I have my 5 here. So I need to have these two boxes are filled in with numbers that add to 17 and multiply to 30. So multiply to 30 and add to 17. And so when I think of all the factors, two come to mind right away, and that is 15 and 2. So 15 and 2, those two multiply to 30 and they do add to 17, so that is 15x here and 2x there. So now I'm going to common factor out the rows and columns. So this way the common factor is 3x, this way it's 1, up this direction it's 2x, and up this direction it's 5. And so we have 2x plus 5, 3x minus 1, and to solve I set each factor to 0. And I have 2x equals minus 5, x equals minus 5 halves, and I have 3x equals 1 and x equals 1/3. All right, so those are my two values of x. And again, a lot of students, when they see this one, they'll think, oh my goodness, that looks awful, I won't be able to factor it, so I'm going to go right to the quadratic formula. When in fact it's actually, factoring this is fairly easy, and the number of steps is much less than going through the quadratic formula. And a lot of students make mistakes using the quadratic formula. So please make sure that if you can factor it. Less mistakes and a lot more efficient. Alrighty, so the next one is, that's the third one. We have 24 equals 2 x minus 3 all squared minus 8, and we're going to solve this. So I have an equation with one unknown, so I can just solve it directly. So I have 24, I'm going to add 8 to both sides, so that gives me 32 equals 2 times x minus 3 all squared. Then I'm going to divide both sides by 2, which is 16 x minus 3 all squared. Plus or minus the root of 16 is x minus 3. This is where I branch off because there's two possibilities. I have the negative root of 16 is x minus 3, and the root of 16 is x minus 3. So negative 4 equals x minus 3. 4 equals x minus 3, and I'm going to add 3 to both sides, so this is negative 1 equals x, and 7 equals x. So there we go. That one's fairly straightforward. Other options here in terms of solving this are to expand this and simplify it so that then they go to standard form. Then from standard form, rearrange it by setting it back to 0 and either factoring it or using the quadratic formula, but that's a lot of work. So I highly recommend just solving directly. All right, the fourth one is 0 equals 2x plus 5, 3x minus 7. This one tends to throw students off because it's already in factored form and it's set to 0. Please do not expand and simplify and then factor again or use the quadratic formula. It is already in factored form and y is equal to 0, so we just solve directly. So we set each factor to 0. So 2x plus 5 equals 0. 3x minus 7 equals 0. So I have 2x equals minus 5. X equals minus 5 over 2. 3x equals 7. And x equals 7/3. There we go. So that one was actually probably the most easy, and this is the one that students make the most complicated. Please do not make it complicated. It's in factored form. Y is equal to 0. You can just set each factor to 0 and solve. All right, last but not least, we have 7 equals minus 5x minus 2, x plus 5. And again, this is where students make a lot of mistakes. This is in factored form, but y is not equal to 0, so I cannot just set each factor to 7 and solve. It doesn't work that way. You in fact need to expand it and simplify it and try to solve using one of the methods after that. So first thing I'm going to do is expand and simplify. So I have minus, and I'm going to use the chart to do this. So I have 5x minus 2, and I have x plus 5. This is 5x squared minus 2x plus 25x and minus 10. So that gives me 7 equals negative, and in brackets I have 5x squared minus 2x plus 25x minus 10. And I'm going to simplify that. 5x squared plus 23x minus 10. And then, bringing in the negative, I have minus 5x squared plus, minus 23x. Minus 23x, forgot the 3, plus 10. All right, so next step is that we have to set this to 0 in order to either factor it or to use the quadratic formula. So I also could at this point change this into vertex form and solve that way, but we're dealing with some kind of nasty fractions here, so I wouldn't recommend it. Alrighty, so I'm going to get rid of this 7. I have to subtract 7 from both sides, so that gives me 0 equals minus 5x squared minus 23. That's not a very good 3. And plus 3. So there we have it. So now we have to, first thing we should attempt to do is to factor this. And when we're factoring, we always make sure we common factor out the negative. So I have minus bracket 5x squared plus 23x minus 3. So I'm going to try to factor over here, so I'm just going to put a line down here to separate the two sides. So factoring, I have 0 equals negative, and then I have my chart. And I have 5x squared, and I have negative 3. And so what I will need to do is I need to have two numbers that are going to add to 23, those will fit in here, and multiply to minus 15. So I have multiply to minus 15 and add to 23. And when I look at that, factors of minus 15, I don't believe there's any that are going to add to 23. My factors are minus 15 and 1, 15 and negative 1, 3 and negative 5, and negative 3 and 5. And if I look at those, none of those are going to add to 23. This is minus 14, this is 14, this is negative 2, and this is 2. So, sorry, Oh, I just hit the eraser. 15, 1, 15, negative 1. There we go. Sorry about that. So these add to negative 14, 14, negative 2, and 2. And none of those are 23. So this is not factorable. So therefore, we're going to have to use the quadratic formula. So I've just shifted everything up. So I'm going to use the quadratic formula, and I'm going to be using this particular form here. So I have A equals negative 5, B equals minus 23, that should be 23, and C equals 3. So I have x plus or minus the square root of b squared minus 4ac, all divided by, I've made a mistake. Sorry about that. I have x equals minus b plus or minus the square root of b squared minus 4ac, all divided by 2a. So substituting in, I have x equals minus 23 plus or minus the square root of minus 23 all squared minus 4 times a, which is minus 5, times c, which is 3. And we're going to divide all of that by 2 times minus 5. All right, so I have x equals, this ends up being 23 plus or minus the square root of negative 23 squared is 529. Minus 4 times minus 5 is positive 20. 20 times 3 is 60, so plus 60, all divided by negative 10. So that is x equals 23 plus or minus the square root of 589, all divided by negative 10. Alright, so I'm going to come up here, and this is where I'm going to branch off, because I have two possibilities. I have 23 plus the square root of 589 divided by negative 10, or I have 23 minus the square root of 589, all divided by negative 10. So I have x equals 23 plus the root of 589, all divided by negative 10, or I have x equals 23 minus the root of 589, that's a 5, all divided by negative 10. So that is minus 4.73, that's approximate, or x equals approximately 0.13. So those are the two possible solutions. So there we go. We've seen when we're solving, again, we're trying to find the value for a particular variable when another variable has another value. We've seen a number of different ways to solve, and some are more efficient than others depending on the situation. So, and also depending on the form we're given. So please make sure that you choose the correct form or the correct strategy when you're solving. So always try to factor, and if you can't factor, then go to the quadratic formula, except for if you're in vertex form, then just solve directly. One other thing that I do want to add is the idea that, again, it's not always the case, as we saw in the very first example, that we actually have a solution. When we look at the quadratic formula, anything under the square root sign, if we have, if anything under here is negative, then we will have no solutions. And same with when you're working in vertex form. If you end up having to try to take the square root of a negative number, then there are no solutions. But please make sure if you have a graph to check the graph to make sure you haven't made an algebraic mistake.